Hello and welcome back, my friend. We're going to be talking about open source intelligence gathering for industrial control environments. And in this video, now this also applies to general IT environments as well. So if you're coming from an IT background or you want to use these tactics and these techniques and tools for IT, everything definitely goes between IT and OT. We're just going to focus more specifically on how to find industrial control systems, most particularly that are exposed to the internet. The main goal of this section is to help us be able to find our control systems that are exposed to the internet before attackers can find them. So if we can find them first, we can fix the issue and not wait until an attacker finds them and compromises those hosts. So let's go ahead and jump into what we're going to be talking about in this part. So you can see we're going to talk about the importance of using, and you mentioned intelligence, but really we're talking about this open source intelligence gathering at this point. So it might sound more fancier using the word intelligence because we might think of something like the CIA or the NSA, but really at the end of the day, we're talking about using open source or freely available utilities or tools on the internet like Google. So we will talk about, we'll touch on the NSA a little bit. So they released a project called ELITEWOLF, which really is just a set of snort rules that we can reverse engineer to come up with some Google searches that will allow us to find control systems connected to the internet. That's one thing that we're going to look at. And then we'll spend actually a little bit of time of looking at how WHOIS information can help us track down a particular IP address or maybe a domain name. Where in the world are the systems associated with this domain name or this IP address, which could be important if we're finding different assets or systems that are connected and exposed to the internet that we want to be able to find where they're at. We're going to look at digital certificates. We're going to spend a little bit of time there and look at how they can expose information about assets and tell us things like who the manufacturer is, perhaps the company that has that deployed, right? Where in the world is it deployed potentially? We're going to look at the dangers of social media, which is a little bit funny since we're watching this on YouTube, or most of you know me from LinkedIn, but we will talk about from an IT as well as an ICS or OT perspective, the dangers associated with social media and how we can use social media posting for doing open source intelligence gathering on a specific target entity. And then the last part of this section, usually probably the most fun you can typically have when we talk about OSINT and industrial controls is how we can use Shodan to find control systems that are exposed to the internet. Because again, the idea is ultimately we want to find the control systems that are exposed before the attackers do, so we can fix the issue and prevent an attack from occurring. So when we talk about OSINT or open source intelligence gathering, we usually have a quick conversation of these different types of intelligence that we can gather. And usually these are terms that we associate with the military or, like we were mentioning earlier, more kind of intelligence services, like in the United States where we have the CIA and the NSA. So where they gather things like human intelligence from spies. So we have actual people out in the field, or signals intelligence where we're stealing or gathering electronic signals as they go over the wire. So, and then there's other forms of those as well, but I think human intelligence, SIGINT, are the big ones that you typically hear. And then there's all these other kind of more specific classifications. But ultimately, what we're talking about is, yeah, not talking about state secrets, and we're not talking about anything complex or complicated. Really, again, when we talk about open source intelligence gathering, it's using information that's out there on the internet. And the vast majority of it is meant to be there shared freely for everybody to access. Now, some things do end up on the internet that weren't necessarily meant to be there, but if it's published on the internet and it's not behind a paywall, which means you're not logging in with the username and password or having to pay for that access, we consider that open source intelligence, no matter how it actually got there. So we want to go back and talk real quickly, just as a refresher, about remember the 5 different ways that attackers are going to get into our industrial control or our OT networks. They're going to get in from the majority of the time, right, from the IT network. They're going to come in and usually through a phishing attack, infect a system on our IT network. And once they have that as the foothold, they'll use that to then transition into the OT network. Remember, that's the vast majority of the time. But we have other instances where we see, what if somebody brings in a USB drive or a laptop, which is a very common occurrence in OT networks, especially for vendors coming in to do maintenance on OT assets. So remember, they're bringing in those transitory cyber assets, the laptops, the USB drives, maybe the smartphones. They're moving in and out of the network. They're designed for that. So we have to be aware of those as well. Now, we see third on the list, well, what about those control systems that are exposed directly to the internet? That was where we saw, just around the holidays in the end of 2023, where the cyber avengers, this hacktivist group associated with Iran, was finding these Ultravision PLCs that were connected and exposed directly to the internet, mostly in water treatment plants or pumping stations. And there was a case of a brewery that we'll talk about as well. I think I've actually already mentioned it in class. And they found these PLCs and they were exposed to the internet. The idea was that they leveraged a default password of 1111, and then they used that to take control over the PLC, essentially to upload a picture to the integrated HMI, the integrated GUI. That basically was their little hacking signature calling card. And we hacked you, down with Israel, basically, is what they were saying. The cyber avengers are great, something along those lines, right? And those entities different, they had to restore those PLCs from backup if they had backups. So hopefully, which they did. So this is really what we're talking about, or focusing on preventing in this part of the course. Now, we've talked a little bit about attackers and the attack process and how they are going to perform reconnaissance against our environment to learn more about our environment before they attempt to break in. The more information they have, the more it makes them successful. I got to work with the U.S. Navy SEALs for about 2 years, and working mostly with the support teams and the folks that support the SEALs when they're out in the field to make sure their mission is successful. And there was always that emphasis on having as much intelligence and information about the area that they're going into before they actually go into there, because it can make their mission that much more successful. So we always have to assume that the attackers are doing reconnaissance against our own environments. We don't ever have any proof, but we have to assume. So we ourselves, the only way we can combat that is to do the reconnaissance on ourselves, to find our issues and fix them before the attackers find them and exploit them. And that's what the main focus in this section is. We'll talk about, yes, there's remote access capabilities, and maybe we can find some of those remote access capabilities using open source intelligence gathering and using tools like Google and Shodan. So we'll talk about that. And then a little bit later on in the course, we're going to focus on the malicious insider aspect. But again, for now, it's about finding our direct exposures to the internet, where we're exposed, and then fix any issues that are associated with those systems that we have exposed to the internet. So I mentioned a little bit earlier that open source intelligence comes from the internet, and where else better to go than Google when we want to start finding information about our target environments, or again, if we're doing reconnaissance gathering against our own environment. And of course, it's interesting because we're at that point where we're going to start to see this transition, and we all have already started to see a transition to using AI tools. So I think Google, of course, and Google searches are starting to get left behind as we now move into Gen AI and ChatGPT and all the other great tools out there that we can just query in a little bit more human language, and then they'll return a ton of useful information back for us. And we can even have ChatGPT models that are designed to specifically for things like open source intelligence gathering, whether it's for IT or OT. So we're getting there, and maybe we'll play with a little bit of that before the end of this section. But when we talk about still today, the tried and true method is always going to Google, right? The biggest search engine we have of all the information that's, remember, it's publicly exposed to the internet. We don't want to worry about, at least at this point, anything behind some type of login or a paywall that we would have to, pay money to access whatever resources are behind that login. We're just talking about all the information that's published to the internet freely to be shared. And I talk about this idea of special Google searches we can run to find particular types of systems or specific types of information out on the internet. And we'll go through some examples, and some will be kind of generic IT examples. Some will build, much more specific OT examples. We'll see how to build these ourselves. But here you can see on this screen an example of a Google dork. So we're using different search parameters within Google, and we'll look at a few of the different ones in a minute. But the idea is you can see that first parameter says I'm only looking for files on the internet that are PDFs. So I'm not looking necessarily for a web page. I'm not looking for a Word document or Excel spreadsheet. I want to find PDFs. And in that PDF, we find the words, the string network diagram. So Google should then return a list of all of the files, the PDF files that it has found, that it's indexed, that have the words network diagram in it. Or I should say the string, right, network diagram in it, the phrase. And so that's a very generic high level, and you can imagine we can get a ton of results. But the idea was we could search through that to see, has anybody left any sensitive information exposed in any of those files? And more than likely, yeah, there's going to be some. Now, are they related to a specific target? No, this is just a very generic search string. We haven't narrowed it down to a target organization. But it's just an example to start the conversation on what a specialized Google search, or again, they use the term Google dork. I think we're just saying specialized Google searches now. Like in this case, to say, find every PDF file exposed on the internet that has the phrase network diagram inside of it. So let's switch over to our good friend Google. And you see I went ahead and loaded file type PDF and the phrase network diagram into a search. And then you can see this is what comes up. So not only is it showing us some images of network diagrams, now granted you can see this looks like a lot of probably demo type of like sales diagrams, some, and then but also for things that maybe looks like some different schools, talking about whether it's maybe for class projects, maybe about the school network itself, and then you can start digging into the results themselves. So again, it's not, imagine these are all the PDFs that Google could find on the internet with the phrase network diagram in them. So if you want, you can start to add additional terms to search for, like if you're looking for a specific target. I always use like Starbucks or Panera Bread a lot often, especially when we're doing these types of demos, because I always do a lot of work from coffee shops, right? And don't have to worry about running into any industrial control or OT like true environments when working with those. So you can add additional phrases or terms that are more particular to a target to then start to focus in. Well, I don't want just any network diagram or any PDF with the phrase network diagram, but what if there's something with like the word Starbucks in it, or Panera, or whoever your target is. So you can start adding those in to make them more specific. I think you get the idea, right? The general gist. Now there's other search options that we have. So remember we looked at file type, which again is I think one of the more popular ones. At least I find myself using that probably more than anything else. Another one that's I've used before quite often is the cache. So you might actually run a Google search, click on the link, and then you go to load the page, and then it's the page is not found. Well, Google knew the page was there before, and it actually cached a version of it, at least a small version. And so you can actually click on, or you can either load that cache with a little click through the Google interface, or you can just tell it, hey, load the cached copy, which is very cool. So again, in those instances where the pages no longer exist, maybe somebody accidentally put up information, maybe sensitive information, and realized, oops, we need to pull it down, which they did, but they didn't tell Google to get rid of the cache. Oops. You can see that Google can also track what websites link to other sites. So sometimes you can find relationships between sites, and we'll talk a little bit more about that as we go throughout this section. There's different information or statistics about a specific page. Not something that I necessarily use. The site operator is a big one. So you can say, this is where, especially if you're looking at a particular target. So let's say my target's Microsoft. So I would say, maybe not as like a target as an attacker, but I'm looking for information related to a support product, maybe the latest, IoT flavor of software that Microsoft has that they're advertising. So I could put in those search terms and then the operator site :Microsoft.com. So then it wouldn't find just any information on the internet, right? The results are limited to information found on Microsoft.com. So we already talked about file type. And then all in title and all in URL might sound like the same, but the idea is you want to look for specific keywords that are, looking at the last one, right? All in the URL. So the address bar, and then above the address bar, you actually have the title of a page. So when you load a web page, that title's there. And so you can also look for keywords in the title of a web page. I know it's sometimes people get confused, but that's the idea. Remember, URL is the address bar where you're typing in www.microsoft.com versus in title where it says, oh, this is the Microsoft homepage. So those are some of the Google search operators, and there's a few others, but those are the more popular ones. And like I said, I use probably vast majority of those, at least on probably a weekly or monthly basis, especially when doing OSINT against particular targets. So I still do some pen testing. So this is a big part of external penetration testing and gathering information about a target environment. Now here's some other examples of these Google dorks, or more, if you want, complex, maybe not the best word, searches that we put together for Google. And I like these. Some of these are a little bit more IT, or some are OT specific, or you can see some that really play in both worlds. And so we can look for, and we can just actually take these. Let's just go ahead and maybe just take one of these and put them in Google. So you can get an idea of what actually comes up. And so by looking for in URL, right, in the URL address, we're looking for top.htm. So there's a web page called top.htm that's been indexed previously. And then in the URL, it also has the term current time. So you can see in this case, the first thing that actually pops up, it looks like, is a D-Link wireless internet camera. And so we can actually go ahead and we can click on that link, and yeah, that's exactly what we found. And you can see it looks like maybe on a golf course or somebody's backyard, and there's like a windsock, which is that's kind of interesting though. And then we'll come back and later on and we'll look at, well, where in the world is this webcam? But the nice thing, especially when we talk about open source intelligence gathering, right? When we're going through and using tools like Google, that's not illegal. Clicking on a link in Google to open up a web page on the internet that's exposed is not illegal. Now, if you start trying to break into that web page that's exposed on the internet, that's where we cross the line. But by just performing open source intelligence gathering, we're not breaking the law. And we can go and you can see, oh, it looks like there's another probably camera down here. We can kind of get an idea of what some of these other things are. So there's a camera we were looking at earlier. Here's another camera. It's kind of hard to tell exactly what the heck that is looking at. Interesting. And then here's another one. So, which is kind of interesting. And you see when you look for webcams on the internet, you see all different types of things. In this case, maybe it's like in a store, maybe in a record store, right? I've seen just about anything you can imagine on the internet, and we'll look at and talk about some of the great examples of things that you can find from the industrial control world, even by looking through webcams, right? And think of a lot of times you find webcams that are on a site, and then is that webcam connected to the IT network? Is it connected to the OT network? If it's connected to the OT network, it's a great way for attackers to get into the environment. Right? So that's one way or one reason why we look for webcams in the OT world, because a lot of times they're on the OT network and they get exposed to the internet with people just not realizing what they're doing. But that's an idea of some of these Google dorks or customized Google searches that you can find. If you want to find, there's kind of this master list. Johnny Long actually was the gentleman that created the idea of Google dorks and created the Google hacking database. The Google hacking database, the formal version, is actually stored on the exploit DB or exploit database, which is hosted by the offensive security team. And the offensive security team is the group also responsible for Kali Linux, for those of you that are familiar, which is normally more associated in the IT pen testing world, but also is heavily used in the OT world as well for penetration testing. But if you go to the bottom of the exploit DB page, you'll actually see that there's a link for, well, it used to be here. Oh, there it is, Google hacking under databases. And so then you can click and you can even see they're continually adding new types of searches. So you can see, I mean, we can just take this first one, right, where you can see that somebody put together. So if we just walk through it, we can see, oh, in text, there's somewhere on the page, it's asking, it says user, right? Maybe a user login page, right? File type is a PHP file. In text is account, right? And then /admin. So it's basically a very generic search looking for, and let's just go ahead and open it up. Looking for admin login pages is really what it's doing. Of course, in this case, you see just a lot of questions related to those types of pages. So you might have to actually dig through some of these before you actually, like here, now you can see here is a account login page that should have admin.php. So not only is it ideally a login for a general user, but it's also an administrative login page. So if I was an attacker, this would be a target. Right? But again, we're not doing anything illegal as far as finding pages through Google and clicking on a link to take us there. If we start trying to, let's say, brute force the login credentials of the web page, now that's where we're breaking the law. Again, it gives you an idea of what different Google searches can do, and we'll look at some ICS or OT specific ones in just a second as well, since this is an ICS OT course. So, but there's plenty of examples that you can see out there that you can play with. Now, the NSA had released, this is probably third quarter of 2023. I think this was actually in response to Volt Typhoon, where the Chinese nation state was found being in critical infrastructure in the country of Guam, as well as then in the United States as well. But the idea is that the NSA had published, and really they called it the ELITEWOLF project. What it was is just a bunch of snort rules. And if you're not familiar with snort is still one of the more commonly and popularly used open source intrusion detection platforms. It's also what Cisco had purchased to make their paid for intrusion detection platform. But you can look at these snort rules and then you can reverse engineer them to essentially create those Google dorks or Google searches that we were just looking for, right? So let's go ahead and we can go to say GitHub, and I'll just put in ELITEWOLF, and it'll come up. So we'll go to the page, and then you can see what it is. Basically, it's a bunch of text files. 3 of them are the snort rule sets, and so you can see there's one associated with Allen Bradley systems, which Allen Bradley or AB was bought by Rockwell Automation. So but you usually see both. There's Schweitzer Engineering Lab, or sometimes you just see SEL. And you'll also see Siemens, right? So if we open up that Siemens snort rule, right? There's not a lot here per se. And you can see there's 5 rules. And then we can come back and look at those. I actually have a SL 1200 sitting in my home lab, if you remember when we were doing the active scanning portion. So I do want to come back and look at those. The one I think that has the most interesting information for this kind of course or for this part is the AB ones, where you can look at the rules, and we can look at the structure of the rule real quickly just so you can understand what we're looking at. So the idea is the first thing you see in alert is, or the rule in a snort rule is, what is it going to do? So if it matches on this signature, right, if it finds what it thinks is, let's say, a malicious attack or potentially a malicious attack, it's going to, in this case, we're going to say, hey, send an alert to the operator, send an alert to the console that the operator can see and know they need to investigate. Right. The rule is also going to watch TCP traffic, so it's not going to watch UDP or ICMP or any other protocols. It's only watching TCP traffic. It's going to watch traffic coming from any IP address from port 80. And then you can see the little arrow, right? So let's follow the arrow to any IP address and any port. So it's a very generic intrusion detection signature as far as the traffic it's looking for, which is very common when we do intrusion detection because we don't know where the attackers are coming from or where they're going to. So we pretty much have to watch just about everything, except in this case they're saying the traffic is going to come related to port 80, which is the default web page or the default port associated with visiting web pages over an unencrypted connection, right? Which is very common in OT networks. Now, if Snort finds traffic related to this rule and it sends up an alert, the alert is going to say what we have here in this message. So it's going to send up an alert that says ELITEWOLF, Allen Bradley, Rockwell Automation, URL path activity, TCP request. Like, okay. And then you can see, well, what is triggering the alert? So you have this content. So it says, if you find this string in this TCP traffic coming from port 80, then you're going to, again, trigger this alert. And then real quickly, we can look at, there's a SID. So this basically specifies it's a snort rule, basically is what it's saying. And then if you make changes to that snort rule over time, you're supposed to increase the revision number, right? And like different version number. Well, what we have here though, right, is if I look here and I take this string, right, well, it's part of a URL. So we see slash rock form slash advanced diags question mark page rec equals TCP, which means, you know what? This makes a really good Google search, right? So if I go back to Google and I just pop that in there. Oh, and then, so Google knows nowadays, right, that if you're looking for this search, you probably might not have the best intent. And so they realize, okay, I'm going to put up, hey, I'm not a robot. Like, especially when we start doing a lot of these like Google dork searches, it essentially thinks we're up to no good, which if we were an attacker, right, we definitely would be up to no good. But okay, so we did their little CAPTCHA gotcha little thingy. And then what you can see is anywhere Google has found this specific URL section. And you see, there's a lot of documentation on, right, these types of Rockwell PLCs. And you can even see, oh, here's the finding for the ELITEWOLF, the GitHub repository we were just looking at. But everything else, right, it looks like when I see an IP address, these are going to be PLCs that are going to be connected. So these are the PLCs that the NSA was highlighting in their project that the attackers are looking for. And so this is where we're looking for, oh, here's a PLC web interface that's exposed to the internet. And let me go ahead and kind of blow that up a little bit so you can actually see a little bit better what it looks like. So here we're actually accessing a PLC. The key here is not only is there a PLC exposed to the internet, but we also see the IP address. So we can use that IP address to then potentially map that to the organization where it's hosted or where in the world it exists. And we'll come back and talk about that in a few minutes. But you can see that's where, oh, we can pull up on this PLC, there's a web page. And then that web page, right, in this case, it displays statistics about that PLC, and it looks like it refreshes that page every 15 seconds. Not a lot of harm here necessarily, other than there's a PLC exposed directly to the internet. At least it's web interfaces. And what if that web interface has a vulnerability? Would that vulnerability allow an attacker to take control over that PLC? And then once we take control over the PLC, that could potentially give us the ability to control the process and the other systems that it's connected to, that it controls. So it's really interesting when you look at the ELITEWOLF, and let's kind of blow this one up as well. So we can look at, those interesting URLs. And a couple of these actually, when you start looking at it, it's like, oh yeah, a lot of these are actually kind of interesting from a, whether it's an admin / attacker perspective. But when you look at even just that second URL, the first listing that comes up is not a PLC. It's actually a listing from the exploit DB that we were just looking at for Google hacking. Except in this case, it's actually saying, hey, there is a cross-site scripting vulnerability in this web interface for these PLCs. And then it even tells us what version. So we don't know what version PLC for the firmware that's running on this PLC is yet. So we don't know if it's vulnerable or not, but it could be, right? That starts to get into that idea of things like vulnerability management, right? Finding the host, finding the applications, the services that are running. Then, well, what version of services or application, and then mapping those to vulnerabilities. So if we see, version 26.8 is running on this PLC, it's like, oh, well, this host is going to be vulnerable to that cross-site scripting attack. And then, of course, we still see, oh yeah, here's examples of PLCs that are exposed on the internet where you can access that web page. right? This just different view, more administrative statistics, right? You can see even it's start to you're always looking for things like IP addresses. In this case, it's a multicast address, so it's not really giving us a ton of information. But you can see now there's also different tabs, right? Ethernet, IP, COM port, then system data. Now I'm not going to click on any of these links to go any further. But then you can see it also kind of flipped over to almost like this home page. So we can see, oh yeah, here's 1769-L36ERM, right? Really the PLC type. And then a lot of times, and you can see the page will refresh, but a lot of times these will also somewhere in here expose the firmware. Again, I don't have authorization to be testing this PLC. We're just looking at a PLC in the default page that's exposed to the internet. Again, so we're not breaking any laws. That's the idea where we can go and create those Google searches. I always find it interesting when you do things like the TCP/CON ones, because if we go and put this in, right, the idea is, oh yeah, you pull up that page, so you're probably already thinking, yeah, it's going to actually show us the TCP connections that are associated with that host. Where this gets to be a little bit more interesting slash dangerous is we can see all the public IP addresses that are connected to that PLC, or at least in this case, have been connected to that PLC, right? Because we see established, that means they're currently talking, or the fin wave could be potentially, something was there and they're no longer talking. And so we see a lot of established connections to a lot of public IP addresses. So on my host, right, is going to be one of these. Let's do, what is myip.com, right? My IP is 7185.4.152. So we should see, if we go back to the right one, yeah, here's my IP address right there. So you can see where I'm connected to that PLC web interface. You can see on port 80. Where it gets more concerning, right, is there's a lot of other public IP addresses, and they're not just connected to port 80, but you can see, oh, there's 44818 as well, which is going to, in this case, be used for Ethernet IP, which is one of those main communication ports we use to send and receive commands for a Allen Bradley Rockwell Automation PLC. And remember, there's 1, 2, 3, 4, 5, 6 different IP addresses. Really interesting. 2 IP addresses in the exact same range, but different IP addresses, right? See, we 198.235.24.56 and .165. That really makes me wonder, is that associated with the owning organization, right? The owner or the operators, or is it maybe an attack group with multiple machines looking at this PLC? The other thing that we start to see here is that it gives us the internal IP address of the PLC. So we can see 192.168.1.253. And it's also talking with another internal IP address at 10.32.140.48. So maybe that 10.32.140.48 could be something like an engineering workstation. Right? So there's a lot of information that now we found, not only this PLC, but we're even starting to map out their internal network. And we're even able to see that, you know what, this PLC is probably being probed and potentially attacked by others out on the internet. So I really enjoyed the ELITEWOLF project from that perspective, because it gives you all of this, all these, right, these Google searches, right? So I think this is like the ultimate example of kind of Google searches for ICS OT. And then we can look at, like, there was, we mentioned Siemens. Again, I had the 1200 controller in the home lab that they were looking at. So you can look for things like, oh, if there's that web page for CSS S7 web, right? That would be a web page running on, if that PLC was running its web interface, then that you could actually pull up. I guess I don't see any that pop up based off of an IP address, or you could do something like in URL, but we don't have to worry about it at this point. Or you can look for certificates. Now, Google's not necessarily the place we're going to look for certificates on websites. Remember, certificates are going to be on websites that are encrypted. They're using HTTPS. So a lot of times in OT or ICS, we don't use encryption. So sometimes you just don't see them. Other times, if we do want to look for them, we're going to actually use Census to look for those certificates. But so we're going to look at Census in a little bit. So we'll look at those. You can see there's not really any web or like specific page names except for this S7 web CSS, and it didn't look like anything is coming up directly other than other references to like using the Siemens 1200. But if you keep looking, maybe one's exposed to the internet. I think those are very hard to find that are exposed to the internet though. So not saying that they're not, but anyways, so I don't want to go too far down that rabbit hole. So again, ELITEWOLF is a great example of things that you can look for. You can look at the Schweitzer signatures as well. So somewhat like between the Siemens and the Allen Bradley, again, for the purpose of this conversation, the Allen Bradley ones are the best because I love being able to take, these URLs or portions of URLs and do a Google search and find them. And again, I'm fascinated, right, when I find a page like this and saying, yeah, not only is port 80 exposed to the internet, which we're hitting, but 44818 is also exposed, and people are hitting that from other public IP addresses as well as internally. So we'll go ahead and save this page because I want to come back and we want to see what this looks like in Shodan. Because again, I don't have authorization to pen test this PLC, so I'm not going to be able to do things like Nmap against it. But you know what? Shodan already has, so we're going to use Shodan to show us that information that it's gathered. So we're going to put a pin in this one and come back. So I'm going to go ahead and get rid of some of these tabs just to clean up some of the mess. But I do want to keep that one sitting there. All right, so let's go back to the slides. It feels like it's been a while since we've been there, right? But that's ELITEWOLF. Again, that's why I enjoyed it, just because I think it, in some ways, it probably, I don't know how much good it provided versus maybe it gave people things like Google Dorks to find PLCs exposed to the internet. But so when we find like IP addresses out on the internet, right? So if I'm back looking at this web page and I see, I'm really curious about these IP addresses, right? Because these are two different IP addresses in the same range. Like, what the heck are these, right? Where in the world are them? But more importantly, where are they associated with? And sometimes we can get lucky and find them associated with a particular organization. And so we can do that with WHOIS. Now, WHOIS is a great tool because not only can you use it for looking for things, and we'll look at some other tools associated with WHOIS and the WHOIS command. So I use a web page called DNSlytics. But when we talk about finding where in the world is this IP address or a domain name, or where are we going to talk about autonomous system numbers or ASNs? But the idea is, especially think if I have a web URL like mycolcom.com, right? That mycolcom.com has to be registered with the Internet registration authorities. And so that registration information is going to be stored in their databases. Now, we see more popular, more and more, and now there's even different regulations in different countries about privatizing that information so it doesn't expose sensitive data about you, right? If I register mycolcom.com, right, I don't want my home address exposed to the internet. I want to go ahead and kind of anonymize that record. So yes, mycolcom is registered, right? Mycolcom.com is registered. No one else can register it, but you also don't see my home address. right? And that's kind of what we'll see. And I mentioned I use DNSlytics a lot. So I like it. And there's other pages I know, and they've changed this a little bit. I'm not necessarily a fan of the newer version. But if I put in MikeHolcomb.com and run a search, and this is where I don't. Before it just used to give you all of the information that you were looking for. Instead, now you have to tell it what part of the information you're looking for. But you can see, okay, MikeHolcomb.com, it's hosted at the Wix platform. So we know, okay, where is it hosting? It's in what Data Center Alley or whatever they call it, where it's the largest concentration of data centers in the world, just outside of Washington, D.C., right? So we have an idea based off of geo IP information where in the world it's located, because sometimes that can be of interest, right? We know where it's at, so okay, it's hosted on the Wix platform. And then we can look for the actual who is information where we're really going to. Well, who is this associated with? Well, in this case, we let them handle all that registration. So you can see Wix looks like it's owned by a parent company that's based out of Tel Aviv, right? So in Israel, right? So I don't even see any information about, right, Mike Holcomb or registered by Mike Holcomb himself or his home address. I see all the information related to Wix, the hosting company for the website. Right? And a lot of times you'll see that privatized information. You don't want that address information. Now, if you're doing work like intrusion detection and you find an attack coming, it's very common, especially like we see attacks coming from at my day job coming from like schools, right? Schools that like universities that get compromised, or it's a overzealous student, right? And so we'll see a lot of attacks coming from schools, right? You want to be able to look up in the WHOIS database to see, oh, this is coming from MIT. And then there should be a email address associated with that, like abuse@mit.edu, where you could send them an email address saying, hey, I just saw this attack coming from this IP address. You might want to know. I'm not going to assume you're going to do anything about it, but right, if we're playing nice citizens, right, we want to share that information because, again, whether it's an overzealous student or an attacker on their network, it's something that they should want to know about and investigate. But that gives you a little bit of an idea of who is, right? Again, let's go ahead and do who is on like one of these IP addresses. Like we were looking at that exposed PLC earlier. So I'm going to go ahead and put in that IP address. Oops, get rid of the URL. So we'll run the search and it says, okay, well, this IP address is in Denmark. Again, it's geo IP information, so sometimes it's not perfect, sometimes it's completely off, but most of the time it actually gives you a really good idea where in the world that this IP exists. So in this case, we're thinking that the PLC itself is sitting in Denmark. Now, this is where we can look for that WHOIS information, because a lot of times this could be associated with a organization. And it looks like this is probably maybe a generic ISP, if I had to guess. Right? Not in English, but when you see things like abuse@grandis.net, I bet if we look at grandis.net, it's probably like the ISP for that area. Maybe let's translate it to English. Maybe not. It's interesting. Users of grandis.net whose internet connection comes via the emergency mast at Volskull, I'm sorry if you're from it, somebody will have to how to pronounce it, are currently experiencing that the network unfortunately runs slower than usual, potentially because it has everything exposed to the internet. Interesting. The supply to the distribution points must come wirelessly apart from fiber. So maybe they're supplying like internet access. It's still, I guess it's the internet provider, maybe for this part of the country that's maybe way out. It's out and away from any major metropolitan area, which is kind of interesting, right? But regardless, again, I can go down too many rabbit holes. But this is oftentimes a lot of what you'll see is you get the IP addresses. Oh, I found this PLC. It's like, well, it's just associated with the generic internet service provider, right? Like in the US, you might see something like Verizon. It's like, okay, that doesn't give me any more information to go off of, right? And if I call Verizon and say, hey, there's a PLC exposed to the internet, we need to help these people take it offline, then they're not going to do anything with it, right? So sometimes though, you'll see it actually registered to the company itself, and so we might come across some of those um, as we go throughout the rest of this section. So anyways, so that's again, WHOIS can tell us a couple things. Let's say I like DNSlytics because here's the geo IP information, here's the map, here's and we'll see some other pieces of information that we'll talk about. But then also, yeah, here's the WHOIS information. Okay, when we were looking at this TCP connections, I was really curious about where these other two IP addresses are. So let's go look at those, and you can see you can just edit the URL. You don't have to go to the search page, right? It says, oh, okay, this one's coming from LA, right? So there's two IP addresses in this range in LA, and you can see they're actually on a DNS blacklist, which means they've been associated with malicious activity previously. So it's going to be more than likely, yeah, this is some type of attacker that's doing something with this PLC that they shouldn't be, right? To some degree. Maybe they're just scanning it. We don't know, right? We're not in a position to know. We just see that they're connecting. Oh, though in this case we can this is a great example of where, oh, okay, you start getting a little closer to the WHOIS information, and you can see, oh, that IP address is registered to Palo Alto. So I suspect like Palo Alto has a service like Shodan, which they're probably scanning either the entire internet for exposed devices, or like in this case, yeah, exposed ports on 44818, right? That we'll look at in a little bit more in detail in a few minutes, right? So that's a great example of how you can take an IP address, look it up in the WHOIS information using a tool like DNSlytics, and then find, oh yeah, here's the company that's actually associated with it, Palo Alto. So we know, oh, it's a security company. Chances are they haven't been hacked. Again, they probably have some of their own scanning entity, or maybe they work with that company, right, to secure the PLC. I don't think so. I suspect chances are they probably have a scanning service like a Shodan that we're going to look at in a few minutes to find different assets that are exposed to the internet, right? So there's a couple of common examples that you see, right? You can look up those IP addresses and find things like ISPs, which again don't really give you that much, because you're not going to be able to go out to the ISP and say, hey, help me track down who has this IP address because they have an exposed PLC. I want to help them. Again, they're not going to do anything about it. It's like 1,000,000 to 1 these days. Or you might actually get lucky, like with the Palo Alto, and see the organization that's registered to that IP address. And so we can see that. And then you can even, might even Google for that IP address. I don't want to take the time here because we're already probably going off track, but then you can Google for that IP address, and maybe you'll see something like, oh yeah, Palo Alto does internet scanning from these public IP addresses. You do see that a couple times. All right. So then there's some of the examples that we're looking through and walking through. Now, I do want to spend a few minutes talking about DNS, because this is something that I realize that not everybody coming, especially from OT, completely is familiar with, at least the nuts and bolts on how DNS works. Where we use DNS to resolve domain names, or we'll talk about fully qualified domain names, to IP addresses. So when you want to go to www.mikeholcomb.com, remember, mikeholcomb.com is just a logical name or representation of the IP address that's assigned to the web server. So when we want to reach out to the web server, we really need to connect to its IP address. So to connect to its IP address, well, we usually are going to have to resolve a domain name to an IP address. We could just use IP addresses, but there's a couple of problems with that. One is, imagine if you had to remember an IP address for every website you visit, right? It's much easier to say, if I want to go to the Starbucks webpage, I just assume it's starbucks.com, right? I don't have to try and figure out what that heck that IP address is. And then you can also have, especially in shared hosting provider environments, you might have 1,000 or 10,000 websites on the same IP address. And so it would be impossible to be able to essentially run the internet without DNS. Right? It helps us people, right, assign logical names to these IP addresses that we have scattered out all over the internet. They also have this idea of reverse DNS, so it allows us to give it an IP address and then tell us that any domains that are associated with it. And we'll see some examples of that coming up. But the idea is that with DNS, I mean, the main function is I want to give it a web address and have it give me the IP address. I mean, that's the base functionality. Now, it's been adapted to also store additional pieces of information in what we call DNS records, and we'll see some of the more common DNS record types. Where this also comes in handy from either an attacker perspective or a pen test perspective is, I think when we're using DNS to map names to IP addresses. Well, the names are there to make our lives easier. So a lot of times people make those names easy to understand, like with an easy to guess naming convention. So if I see something like PLC01 in the name, right, it's like, oh, okay, well, that could be a PLC. And not only is it a PLC, but it's the first PLC. So maybe does PLC02 exist? Oh, it does, right? That gives you an example of, again, easy naming convention, right? It's great to help us humans remember things, keep things organized for administration purposes, but it also helps the attackers in some respect. So now how DNS works, if you're not familiar, so you can see I'm starting off down here, and let's say I just want to find, hey, I want to go to the web page for panerabread.com. So I say, my browser is going to say, well, what is the IP address? Well, my system, but you get the idea. But it's going to say, well, what is the IP address for www.panerabread.com? Well, the web browser in my system is not going to know that by default. So what it's going to do is it's going to check my local DNS servers, right? Again, whether I'm at home or at the office, and says, hey, what's the IP address for www.panerabread.com? Well, it's not going to know by default. It's going to say, I don't know. But what I can do is I can take you out to what we call these root DNS servers on the internet. And there's a handful of them scattered out all over the world. And we're going to ask it, hey, what's the IP address for www.panerabread.com? And those root servers, a root server is going to say, I don't know. I'm not responsible for every freaking website in the entire world. All I know are top-level domain DNS servers like .com, .edu, .gov. Like, oh, okay, well, I'm looking for panerabread.com, so send me to the .com DNS servers, right? So it's going to give us the IP address, or it gives the DNS server the IP address for the .com DNS server. So then we go to the .com DNS servers and say, hey, what's the IP address for www.panerabread.com? And they're going to say, I don't know. I'm not responsible for the www part. I'm only responsible for anything directly under .com. You're looking for www.panerabread.com, so I can tell you where the DNS servers for panerabread.com are. Go ask them where www is. And that's what happens. So, okay, we'll then go to the panerabread.com DNS servers and say, hey, what's the IP address of www? And then, oh, you can see he or she comes back and says, oh, it's 184.27.24.247. Then my browser gets that information from the DNS server, and then it's able to make the connection to the web page. So anytime we're making a connection to a web page, right, we have to go through that resolution. But it's not just one DNS server we go to. It's this whole chain of DNS servers to finally get that one IP address. Right? It's a kind of simplistic system that actually works. I think there's a lot more servers, right, that are involved than we actually realize. Right? The nice thing is that If we understand how that process works, we can kind of reverse engineer it though to help us gain information about different target environments. And where this really builds into is one of my favorite tools of all time called DNS Dumpster. Because DNS Dumpster, I didn't know about this till like 4 or 5, man, maybe 6 years ago at this point. But when I first found it, I was like, oh my gosh. Because the nice thing, you're usually used to do a lot of reconnaissance, and sure you would use Google, but most of the other tools you would use were tools in Linux or maybe a command line on Windows, but it was all command line. In this case, DNS Dumpster is a really simple web page that you can use. So we just go to dnsdumpster.com, right? And then you can give it the domain name of your target, right? So if I'm using, let's say, starbucks.com, right? Oh, there's an error getting the results. Oh, let me just type it all the way out and not try to, there we go, using cache, because you can see I always use, again, Starbucks as an example. And then it's going to come back and it's going to give us, I think, and it's on the web page, it's going to limit the records up to 100. There is a command line utility or functionality built into ReconNG. ReconNG is a tool written by actually my friend Tim Tomes, and it's that command line utility to do open source intelligence gathering. It's lost a lot of its functionality. He'll be the first one to tell you over the years, because a lot of things like search engines have really clamped down on the different types of searches you can do. But anyways, if we, for this purpose, we have 100 results. You can do 500 through ReconNG for free, which is awesome. Or you can pay for DNS Dumpster to get all of the results, right? But what we can see, even just in this free default layout, is that Starbucks is, we're going to get 100 DNS records. Out of those 100 DNS records, not only we see the main DNS servers that are listed, and that actually can come important. You can see one's actually in the US or the UK, it looks like. You can see where they're hosted at, and oh, they're behind iron port systems, right? Which are, there's a layer of cybersecurity there, essentially. And then what we were mentioning earlier is that DNS can store more than just IP addresses and domain name mappings these days. So you can also store things like text records. And well, yeah, you can literally put anything in these small text records. Now, a lot of them are to do things like verify application connectivity, especially think of like with sales ads and things. So that's why you see things like, oh yeah, Facebook, Google, Apple, right? That's a vastly, that's a lot of what you're seeing there. But then sometimes you can also see maybe product associations that the company itself is working with. And then I was like, oh, well, like, I wonder what this is, right? Oh, maybe is it some type of hash? Or, again, I'm going way off the deep end, so I'll reel myself back. But that's the idea of text records. What we're really getting to, though, are these host records, or some, they say the A, or the address record. And this is where we have a fully qualified domain name, right? So we have a host name and a domain name that come together, and we have the IP address that is associated with, and then we weren't spending a lot of time on this, but especially when we get into more kind of general external pen testing, one of the things we want to look for is the autonomous system name, or ASN. And that ASN, really what we're looking for, to keep it simple in this case, is what organization is it associated with? Because I can see here, oh, here's something associated with Akamai. Oh, that's starbucks.com, right? So if you go to www.starbucks.com, you go to Akamai, where the website is hosted. It's like, if I want to break into the Starbucks network, I'm not going to break into their web hosting provider probably, right? Because it's not going to give me access to their network, right? Same thing with fb1.starbucks.com. Whatever that is, it's hosted by this organization, whatever, Kogeko-Peer 1. Not sure what that is. Again, it could be a tangent I'm going to chase, but not today. But then I start seeing, ooh, Starbucks, 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 Starbucks. And we can also associate this with these IP addresses. So anytime I see something that starts in a 9899 range, that could be associated with Starbucks, right? Because they also see 9899.254. So it's going to be a little bit bigger, right? I see 104. Well, it's not the 9899. Oh, yeah, because that's Microsoft. Oh, we see 9899 again. Oh, there's Starbucks. So you can start to figure out what's potentially on the Starbucks network versus what's being hosted out in the cloud. So if I'm an attacker, right, I want to get on the Starbucks network. So again, more than likely, I want to find a host that's on the Starbucks network that's exposed to the internet that I can break into and then have that as my foothold onto the network. So just kind of keep that in the back of your mind. Because why we're here, though, is we want to go back and we want to start looking for some of those DNS records that are associated with, in this case, like Starbucks.com. Because if this was an OT environment, right, if I saw something like EWS, I would think engineering workstation. So this would definitely be a potential target for me. Right? And a lot of times, right, we can see mrs2.starbucks.com. We don't necessarily know what that is. And then, oh, there's MRS3 and so on, right? What if I saw payroll.starbucks.com or portal.starbucks.com, right? A lot of times the DNS names can give us like hints as to what's actually there. So they can make kind of targets pop up to the top of the list. Like when we were mentioning earlier, the example of PLC01. So again, it's not illegal to use DNS. It's not illegal to use DNSdumpster.com, right? This is all perfectly legal, open source information that's available on the internet, right? This is the whole point of OSINT and OSINT gathering. So I love DNS Dumpster because it can pull back that information. Nice GUI interface. Takes 2 seconds. Oh, and at the very bottom, they give you this little, they even put a little kind of flow chart together, kind of map things together, which can actually sometimes be useful or sometimes not. Let's trying to make it a little bit more readable. So you can start to get the idea of what systems might be connected together. Like in this case, right, here's this test one for secure payment hub. Paymenthub.starbucks.com. Oh, and it's behind like a big IP, kind of like load balancer, kind of reverse proxy device. So lots of interesting information. So you can, if you're doing things like a pen test, or again, if you're an attacker looking at targeting an organization, like if it's Starbucks, here's where you go. It's a great tool. Again, it just maxes out at 100. So if you're doing a larger organization, use Recon NG with the free utility or with the free module for Hacker Target, which is the group that put DNS Dumpster together, or just pay for an account with DNS Dumpster. I don't think it's very expensive. I've never had to pay for one. So that's DNS Dumpster. Now, digital certificates is what we were mentioning earlier. We don't see a ton of these in OT as much as we do in IT. In IT, right? They're everywhere. Every device, every asset in an IT world these days has a certificate if it has some type of web interface, right? There's some type of web interface, and we want to make sure, no matter what, that traffic is encrypted, whether it's sensitive information or not. We just encrypt everything, right, in the IT world these days, because it helps us enforce that confidentiality, right? The main focus of IT cybersecurity. So we ensure confidentiality by encrypting everything. It's very different in OT. A lot of people are still trying to get to encrypt everything in OT to protect it. Well, remember, confidentiality is not our main objective in OT, right? It's physical safety, environmental safety, plan availability. If introducing encryption could actually potentially put those at risk, it's not something that we actually want to do. But but some devices, right, in OT do have web interfaces. And right, some owners and operators, and I'm not saying there's not times and places where you wouldn't, right? Where, okay, let's go ahead and encrypt that traffic. Why I argue sometimes against encryption, just remember, if you're encrypting data, it's going to slow it down. So if speed is ever of an issue, especially in OT environments where you need real-time responses, right? Encryption is just not going to happen. If that's not an issue, okay, that's okay. But encryption also, right? It's just going to prevent us by default from reading network traffic, right? Which is what it's designed to do, right? To prevent attackers from reading network traffic. Well, if we're the defenders, by default, right, encryption is not going to allow intrusion detection systems, something even like Snort that we saw in the ELITEWOLF project. It's not going to allow us to read the traffic to see if there's potential malicious activity on the network. So if you do have encryption within the OT network, you also have to have the tools to be able to break that encryption and inspect the traffic to see if something malicious is happening or not. And that's where a lot of those conversations kind of go awry, because people want to sell you the encrypted solutions, but they don't take into consideration that you also want to break the encryption to be able to read it to see if there's malicious or suspicious activity on the network. So just keep that in the back of your mind. So here was an example that I found with digital certificates, where there was actually, I just looked for all digital certificates with PLC in it, and I actually found there was this one that came up, plc-city.com. Which is, it looks like it's a PLC vendor, which I thought was kind of interesting. But this gives you an idea of, if you go to that website, right, that website has a certificate, right? The certificate is what we use, kind of acts like your driver's license or maybe your passport or your other government ID. It identifies you. It, makes you appear legitimate. It should provide your credentials so that you are, seen as the legitimate you, right? So that way you can do the encryption. So somebody goes to plc-city.com, right? They're going to get redirected to HTTPS, the encrypted version of the website, to transfer information back and forth, right? So I thought that was kind of interesting. You can find one of the better tools to look for certificates is actually called Census. I stopped using Census for a while. I used to love them when they first came out. Then they got rid of their free accounts. And so I said, well, like, it kind of stopped talking about them, and then I had a conversation with a gentleman from Census, and he's like, "Oh yeah, we actually reinstated the free accounts." Like, oh, that's cool. It's really hard to find on the website. I don't know why they make it so difficult, but let's go over to, so it's censis.io. And Census is also, it came out a little bit after Shodan. I mean, it's from my perspective, a little bit after Shodan. Try to do the Shodan thing, and it does some of that. And then I think they just kind of took two different paths. Shodan definitely has always had a focus on what things like ICS or OT devices are connected to the internet. That was its original focus, and in many ways still is. Where Census kind of does that, but it doesn't have a strong focus on ICS OT or things on the internet necessarily. But also where it does a really good job of enumerating all of the digital certificates out there. So if you scroll all the way to the bottom and then click on Census Search, and then do we scroll all the way to the bottom again? So this is why it drives me crazy, because it's like, oh, maybe it's, oh, go Census Search here. We'll do their little Cloudflare to verify we're legit users. And okay, so now this is kind of like a Google search page, right? And again, this is just the free account. You can see their indexing 250 million IP version hosts. Here's the IP version 6 host, right, virtual host, and 3.3 billion services. So there's a lot that is looking for. Like we can go ahead and maybe we just take this IP address from our Palo Alto friends earlier, right? And we can put it in there just to give you an idea of like what Census can show you, right? So it's kind of like the DNS lytics, kind of, right? So I see a map where in the world it is, which is interesting, right? Because this actually shows us Belgium versus the other map showed us LA. So it's like, I wonder which one's correct. Probably the LA one, but like I said, geo IP information is not either accurate, or in this case, you have two different sites that one has a more up-to-date database than the other. Right? Now you can see also, hey, we have more information about that host. So we can see it's running Ubuntu Linux 20.04, right? That's really specific. We can see it has services like NTP. There's a website running on 9100, and SSH is exposed on TCP port 15273. All right, so it gives us that information. And here's even more details about those three different ports that it actually found. Again, we're not scanning the internet, but Census is doing the scan, so we can look at that information. Or let's go ahead and take our little AB Allen Bradley PLC and pop it in there. Oops, we have to get rid of. I always do that. Just put in the IP address, right? Because remember, we at least saw two ports exposed from the interface because we could see IP addresses connecting to two ports, 44818, which is Ethernet IP, and then we saw the web interface on port 80, not encrypted, right? So no certificate. So here you can see, oh yeah, there's more information about that web server that's built into the PLC. So on the PLC, they built in the go-ahead web server, which could that potentially have vulnerabilities over time? Yeah, for sure. And you see, oh yeah, the HTML title, Rockwell Automation. So remember our Google dork searches earlier, we had, oh yeah, put in the title, just search for Rockwell Automation. Might be another way to find these PLCs. You can see it's also running SNMP. So if SNMP is not secure, we could do kind of this brute force walkthrough of it to get more information about it. In fact, actually, they did. So you can see it actually even gives us the specific PLC, which we saw on the other machine, right, on the web page. But if I just pop that into Google, right, here's a picture of that PLC that we're actually looking at, right? We're looking at one of these devices that's connected out there, out in Europe, and it's exposed to the internet. So always, again, it's more, okay, that's great, we found it. I always wonder, well, what is it connected to, right? What does it control? It could be something very simple or something very complex. We don't know. That's always usually the mystery that you have to unravel as like a pen tester or as an attacker. Again, we don't have authorization to go. We're just looking for exposed assets. But why we wanted to look at Census, besides where it has this kind of Shodan interface as well, and here's information that it was getting back from port 44818, and that you can see it's just returned basically the model number, is that Census does a really good job of indexing those digital certificates. Again, digital certificates are not as popular in OT as they are in IT. They're everywhere in IT, but we still see them in some places. So remember when we were talking about, let's go back to our ELITEWOLF project in the GitHub repository. Remember in the Siemens rule set, there were rules associated with different types of content that we would see in certificates. So here's one for, S7 1200 controller family. It's one of the most common types of Siemens PLCs. I have one sitting in my home lab. So we can go ahead and let's go back to Census and run a search and see what it comes up with. And now we can see here's all these devices that come up with a S7-1200 controller family string, more than likely in a certificate. So when I look at these on the surface, I'm a little skeptical based off of all of the, like some of these ports, right? But then like if I get down to this one right here, it's like, ooh, we see TCP 102, which is associated with S7, which is the protocol for Siemens PLCs. And remember, Census, it's sitting there and it's scanning the entire internet for all of these ports and certificates to pull in these certificates. And then you can see, oh yeah, it found this IP address in Poland, in Warsaw, right? And it has S7 open, and they even have it marked as a ICS port slash SCADA. And that it even pulled model ID information or module information from the PLC. And a lot of times, and this is where I used to do a lot of research with Census, you could actually go into all of the data that they were pulling to actually find even additional pieces of information, which in this case, we really don't see anything else, right? We see the public IP address, right? See it's S7. We can maybe Google for that module ID. But then here's where it's, oh, there's a website running on that device. And it's encrypted traffic, which means it has to have a certificate. And that certificate had that string we were searching for, S7-1200 controller family. And not only that, but it even shows us the internal IP address of the host. More than likely, right? When they created the certificate is what happened. And then they also even give you this little, oh, click go, right? So it says, oh, you want to go visit this webpage? I'm going to assume it's not malicious. And so we're going to open it up. It says, oh, there's probably some type of certificate issue. Yeah, because it's self-signed certificate. And then we'll say, oh, I want to continue to actually load the web page, which, yeah, it should be the web page to help control that, in this case, that Siemens S7-1200. And that's exactly what it looks like. That one has some additional modules than my my home. I'm not going to click enter. I'm not going to click on anything else on the web page, right? That's where we cross a line. But that's how you can use web certificates through, again, Census is the best place to do web certificate searches because that's one of its focuses. Shodan doesn't focus on web certificates. Can it come across that data? Yes, but it's not going to be as specific, or you're not going to have as many results as you're going to see in Census by far. Again, digital certificates, not as common in OT, right? They're everywhere in IT. OT, again, we kind of stay away from encryption because we don't want encryption because it will not allow things like intrusion detection systems to, by default at least, read that traffic to see if there's any suspicious or malicious activity in the traffic. All right, so let's get back to our slides. So we also want to talk about, well, what information can be exposed from social media. So now these are pictures that I got from the PLC subreddit, which I always find fascinating, right? Because I get to work in a lot of environments, but it's interesting to get to peek into other people's environments as well. So you have a lot of PLC technicians on that subreddit that they're either like taking pictures to say, hey, like kind of like this middle one. It's like, hey, here's my new job, and isn't it pretty, and isn't it look awesome? Which great, that's awesome. Or you get kind of ones on the left where it's like, look at this, like it's all falling apart or it's all a mess, right? It's a joke, right? Or the one on the right, hey, I have this really old environment and I'm having issues with this device. Can anybody help me? I don't even know what it is. Help me, right? Those are the types of posts that you see. When you start to think of, well, can you even track that information down to the particular environment? And sometimes there's things, in the environment, there's clues to tell you maybe what company or even maybe what site that is. So you have to be very, very careful. You shouldn't ever actually be posting any pictures of any equipment on the internet, let alone to social media, because there's just too much risk there. I understand when people are proud of their jobs, right, and they want to show it off or showcase it. If you're going to do something, make sure A, you get the authorization of the client to do it first, and then B, make sure it's scrubbed to make sure there's not any sensitive information exposed. Because sometimes you could have information where, like in this one, if you zoom in, right, you can see things like the different model numbers. You can see if like the PLC is in run mode or stop mode, or you can see maybe other sensitive pieces of information. Sometimes I've seen like you can see like literally the the stickies with the password written down. So you have to be very careful on what's exposed or what's shared to the internet. Again, if you want to share off that latest and greatest job that you did, great. Just make sure you get authorization from your client. And also when not only that, but make sure you scrub it for anything sensitive, which sometimes isn't as easy to do. So just be very, very careful to what you're posting. I also, find a lot of interesting information on LinkedIn, right? You would think, like of all places, right? But LinkedIn is the main profile or the social media that I use, right? That's how most people find me. I used to always think of, and this was me even up to like 9 months ago. Oh yeah, LinkedIn is like your, it's where you do your online resume, so people can find you, or you can, kind of stay in contact with people that you meet, like at conferences and stuff. Like whoopee, right? I used to, tell my students, hey, join my LinkedIn community so you can connect with the people I know. So potentially, maybe someone in my group, knows of a job for you, right? But we can have a lot of sensitive information that's posted to LinkedIn. And we've actually, in my day job, right, and I can share this because I'm not sharing any sensitive information, but we actually had a client one time where we had $1 billion in liability if we were found to have disclosed information related to this proprietary formula they had for creating, let's say, just a special type of liquid. So if we exposed that special secret formula, that we would pay them $1 billion essentially. And so they actually contacted us one time to say, hey, we just saw one of your employees posted on their LinkedIn profile, and it had a picture of them sitting at their computer, and you could read the monitor, and you could read the data on the monitor, and part of that data was part of this top secret formula, which that was, ooh, like that's obviously not very good. That was one of those scary moments where you feel like you get punched in the stomach. And then we went to track down the employee to talk to him about this and realized, oh, it was one of the employees for the actual client. So it wasn't one of our employees. It was one of their own employees that put this picture out on the internet that exposed part of this chemical formula. And of course, obviously, it got taken down and it's not exposed any longer. But the idea is it's an example of, yeah, people don't always think of what they put on social media, whether it's LinkedIn or elsewhere. Right? The always common example is people, on their first day of work, posting a picture of them with their badge. And then, attackers can use that to create a fake badge, at least, to make it look like they have a real badge. Obviously, it doesn't work, but if they're walking behind somebody into a building and that person badges the door open, nobody's going to ask them. It's like, oh, where's your badge? Oh, my badge is right here. I've done that in pen testing before. It works all the time. LinkedIn can be used to find other sensitive information as well. So if you look up, maybe there's more and more, people like that do operations in OT environments like PLC technicians. And if you find maybe a PLC technician for a particular plant, right, he could, or she, right, could list, right, the different types of assets that they work with. So what types of systems are actually in use at that plant. So if I'm an attacker, right, I'm going to start looking for vulnerabilities in those types of systems and get used to being able to attack those different types of systems. So that's why we always encourage employees to put as little information in LinkedIn as possible. But it's a hard sell, right? And we understand, sometimes people put that information as part of their resume. Hey, this is what I do, because they could be open to open to other opportunities. So that's definitely a tough conversation sometimes to have. But at least, there's this idea of make sure we're not posting any pictures with sensitive information, right? Because here's a great example, right? So on the left-hand side, here's this great, this is a demo that was designed. It was posted on LinkedIn, and you can see by Trace Automation, and it links to their YouTube video, right? That's a demo environment, right? So everything we see there is designed, right? It's not sensitive information. Whereas on this other side, where I saw where there were these two guys that were showing off, they're at home, right, doing work in this guy's bedroom, right, and doing PLC programming that they were showing off, and it's like not a demo, right? It's showing sensitive information. So again, be very, very careful about what we're actually sharing. All right. So that will bring us to the kind of the last part of the section when we come back and talk about Shodan, which we got kind of a little peek at Shodan functionality because we did look at census, but we're going to come back now and look at kind of Shodan from start to finish. So Shodan was created by a gentleman named Jonathan Matherly. You can see back in 2009. So it's been around for a while, and really came up as this search engine to really allow them to find things that were connected to the internet, not just web pages like Google or at the time like Yahoo, but things, right? And the big things was internet control systems. And so it was really kind of the whole kind of idea behind starting Shodan: scan the internet and find control systems that are exposed to the internet. And you can find it at shodan.io. You can see not .com. I do have a quick start guide, and there's one version for IT, and then this is the version of ICS OT up on my GitHub repository. So if you go to github.com/utilsec, and then there's it's like, I think it's quick start guides. You can, or OSINT, either or. I think there's both. So, but you'll find the Shodan guides for IT as well as for ICS OT. And this is a lot of what we're going to actually walk through for the rest of this section. And really what we're talking about here is when you open up Shodan, and here I'm logged in already. I have a kind of, my account is one up from the free account. The free account is fully functional, but I think it limits you to, I think, 2 pages of results. So I don't have don't think necessarily a limitation on the pages of results that I get back. Now there are some features that you can get in the more paid for, the higher price tier. The pricing though, if you go to just to look at it, like there's this, I think the freelancer, I think that's the account I have. We got it actually through the grid glass because Rob Lee knows Jonathan Matherly and just asked him to upgrade everybody's account. And then you can see small business. That probably fits most, but if you want to get to where you can use tag filters, like show me all the ICS devices that you've found and label them as such, that's $1,000 a month, $1,100 a month. Probably, most folks are not doing that, but they're very busy, so they actually do have a lot of folks that actually pay for those, I'm sure. But just on a side note. But anyways, so, and it's funny because I actually created the cheat sheet. Oh, I went ahead and closed it. And Shodan used it. They've actually adjusted it over the years to update it, but some of the original stuff still exists. Like when I built it, I lived in San Diego, And so you can see, oh, use city to type in the name of the city. And then I also did like things like New York because we're getting ready for a New York trip and things of that nature. But so they used it. Census actually did the same thing, and I had a census cheat sheet, and they put it on their website as well, which so was nice. I never got any credit from anybody, but it was kind of cool to see it. And then I do see other people that steal them and put their name on them, which is, I guess it's expected to happen. I actually saw that Jason Haddix was using a version in one of his courses that I'm like, oh, that's my cheat sheet, and that was like had somebody else's name on it. I was like, oh, because I thought, I'm like, oh, I really like Jason Haddock. I always watch his. I mean, he's like kind of the godfather of open source intelligence gathering. So to have like my like cheat sheet in his course was really exciting, and then I saw it's like it didn't have my name on it. I was like, oh, so, but it was there regardless. So anyways, so where I start with Shodan, and this is where I started back the day. It looks very similar to when it started. If you go to explore, and you can actually see all these different parts or sections of things that they've indexed. And you can see the first thing is industrial control systems, right? And I remember going to this page, and this is exactly how it looked. And not only it's like, oh, okay, here's kind of the plant, environment. Could be some type of mining operation, or it's hard. It's not a huge picture. Well, probably not mining. Maybe petrochemical. See some storage tanks. Could be a little bit of everything, I guess, out here. But anyways, so you can see what we're listing here, really, and they could say here's some common terms, but what we're looking at are some of the more common industrial control protocols. So we can see, oh yeah, here's Modbus. Now this is the version of Modbus that runs over TCP/IP, right? Because we're finding these exposed to the internet, and these are not the original versions of Modbus that did not run over TCP/IP. Right? So we see S7 that runs over TCP/IP. Again, not the original ICS OT version, and so on and so forth. So DMP3 BACnet, which is in building automation, right? Ethernet IP, which is what we were just talking about, looking at 44818 on the Allen Bradley PLCs, right? So this is going to factor in, right? Tritium, HART, Phoenix Contact have one of their PLCs. Long story there. Code assist, right? A couple of other types of platforms and protocols that we can find through Shodan. And that's a big part. So you can start with that explore option, and then if you want, I could just click on explore Modbus. And what you'll see is Modbus and TCP/IP by default runs on TCP port 502. So really what they're doing is, and you can see here, is they're just saying, hey, show us a list of every device, system, or IP address on the internet that has something running on TCP 502. Now that does not necessarily mean it's Modbus there. It just means something is on port 502. So this is very generic. So when it says there's 518,000 Modbus devices exposed to the internet, no, there's not. Right? A lot of these are other types of devices that just show those ports open. Sometimes you go to these, and sometimes you'll see like things like at internet service providers. Sometimes it's like one of their routers, maybe even like a firewall that they manage, and it shows like all ports are open, even though there's no ports realistically open. They're just playing games with you. So a lot of this is right. These are not type control system assets, right? But what you do start to see is when Shodan does find an open port, it will send like Nmap did previously when we looked at it in the previous part, that it can send additional requests to an open port to try to get more information back. So if it sees TCP 502 open, it can send more query traffic to it to see, hey, is this really Modbus? And if it is Modbus, well, then what other types of information can I get from it? So in this case, it is getting some type of response that makes it look like this could really be Modbus. Right, because we see things like slave ID data, right? IDs 1 through 55. Right? It's querying it, but maybe it just doesn't have permissions. But it probably could be some type of PLC, potentially. And that it even, Shodan labels it as ICS, right? Which you can see there. And then you can just page through these. Eventually you'll find one that does expose more information. So there's another one that's not very talkative. Um, that's looks like it has SSH running on port 502, right? Again, this just shows us everything with a service on port 502. Again, here's another one where you just really don't have access. I'm trying to find one that's very talkative and kind of wide open. I'm not seeing one. We'll do one more page. All right. Anyways, we'll come back and see some much better examples. I don't want to waste too much time there. Right, but you can see start with the explore page, right? And you can, and obviously there's other different types of assets that it looks like databases. You see network infrastructure for like routers, switches, video games, etc., etc. But so we look at those, and again, if you want to dig into those, like Siemens S7, right? We were just looking at the S7 to 1200 PLC, right, and so on. So it helps you find these different types of assets. There was a really interesting BACnet example I came across. This was actually when I was teaching at the local Greenville Technical College here, and I wrote all the labs. And in the final for the course, the students would use Shodan to do a lookup. And I had found this example, and the first example was a BACnet exposure, and it was actually in Greenville, South Carolina. It was like where I live. It was like, oh my gosh, like who would have thought, right? It was the first example, and actually turned out to be it was for a kind of the control system, the building automation system that was responsible for basically the heating and air conditioning at the dean that runs Furman University, which is one of the larger universities in the area. So that's all it was, right? It wasn't anything, of true consequence, but it was an interesting example to use for the exam. Now, Shodan does have these tags, and we had seen one earlier, right, where Shodan, when it realizes, oh, this is a control system, it will tag it as ICS. Or if it sees it, oh, this is a web server, it'll tag it like as a web server. Or if it sees, I'm trying to think of some of the other ones, honeypots, right? It'll actually tag those as well. But again, you have to have the $1,100 a month corporate account to be able to do tag searches, which I do not have access to. So we will not be running those searches. But here's an example of where we found a control system asset that Shodan labeled as ICS. And you can see in this case, here was probably a Modbus instance where it was getting much more information besides denied, right, or prohibited, or no information. It was, oh, here's a Schneider Electric, right? Here's the model number, and even probably the version of the firmware that's running on that system. So we're actually getting a lot more information coming back. And since it got that information and it matches a type of control system, it goes ahead and tags it as ICS. We can go ahead, and it's always, this is where I always like to, take the model number, right, and stick it into Google. I don't like using Bing. I should always change my search engine over. But so I do, like, you can do like Schneider, right, if I can spell it right, TM251MESE. And then it's like, oh, you can look up in Google and say, oh, this is exactly what we're looking at. Right, so it's this Schneider Modicon, which is one of the more common PLCs that have there, and it's one that has a lot of known vulnerabilities in it as well. I actually have one of these in my home lab. There you go. So that's, you see, it's one I bought off of eBay, so it's not brand new. You can see it's been, I mean, not beat up horribly, but it's definitely has a few little dents and dings in it, right? But it was always interesting, right, when you find that model exposed and do the lookup and realize what it is. And I was like, oh, yeah, I have one of these. So we did mention this idea of honeypots. And if you're not familiar with the honeypot, the idea is a honeypot is a system that's designed to be attacked. So usually you create it's a fake system. Right? You make it look like something else, and then so in this case you would create a honeypot to make it look like, let's say, one of those Schneider PLCs. And so if you were an attacker scanning that IP address remotely, everything on the surface would make it look like it was a Schneider PLC. Even though behind the scenes, maybe it's like a Python script or some other utility running, maybe like on Linux usually. But the idea is that honeypots have really two main purposes. The one that I came across originally was just it's very fascinating still to me to find like run a honeypot, and when it's getting attacked, you can actually sit there and it allows you to watch what the attackers are doing. So then you learn like how attackers break into systems. Once they're on the system, then what are they doing? What are they trying to do? What are they trying to accomplish? I remember the first honeypot I put up 20 plus years ago at home. All it was getting attacked for was people wanted to, and they were coming from all countries in the Middle East, or they were using it to get around their country's porn filters. And so they were popping on this box, and then you could see they would use some type of attack to gain access, and then they would use it to search the internet for porn. It's all pictures back then, before video, right? Um, so it was interesting. In fact, you could get to see again how attackers were doing what they were doing, and they nothing fascinating. I didn't see like anybody trying to break into a bank or a government installation. It was just all look at porn pictures on online. But you can use honeypots to again watch them being attacked and learn how attackers are attacking things, how their attacks, their tactics and techniques, maybe they're evolving over time as well. But it also is my number one go-to for when you talk about intrusion detection on whether it's OT or IT networks. Because if you put one of these honeypots on your network, the idea is that nothing should ever connect to it. And if it gets connected to, then something's going on. Right? Is someone scanning the environment? Is there an attacker in the environment connecting to this honeypot? So if you have a honeypot in the environment, it generates what we call high fidelity alerts. It means if it gets hit, if it sets off an alarm saying, hey, somebody just hit me, it means you need to jump on it right away because 99.9% of the time it's an attack. The other 0.1% of the time it's there's someone in the environment that they're an employee, maybe a PLC technician that just thought it would be interesting to run Nmap across the local subnet. Either or, it bears investigating. So if you ever get an alert on a honeypot, right, jump right on it and go into action. It's that high fidelity, right? It means something is going on in the environment, and more than likely, it's an attack. Right? You don't get that type of fidelity with any other type of security control. So honeypots are vastly, I mean, they have are very useful. So honeypots are very useful from that intrusion detection perspective. And we're going to talk more about those in the, as you would imagine, intrusion detection section, so which we have coming up. And hopefully I've been playing with creating my own little kind of like mini honeypots, nothing super complicated. There's a couple of other large suites out there, like we'll talk about Teapot and Conpot. I've been playing with like Python scripts just to create some really simple ones so you don't have to get it convoluted. If you just want something like really super simple, that you literally just point and click and it works type of thing. So we'll see. I'm using ChatGPT. I'm not a developer, but I'm just having ChatGPT code it for me. So, but yeah, so honeypots are really interesting. I've always been fascinated with them. The idea of honeypots and the HoneyNet project actually was created by Lance. Oh Lord, I'm drawing a blank on his last name. I can see his picture. I've talked to him from time to time over the years. So it's really, and he now runs the security awareness program for SANS at the SANS Institute. And does all the courses and their whole community because and I always found it fascinating because here you have this gentleman that is very technical and I really admired from this whole idea of creating honeypots. I mean, I was just amazed. um, Spitzner. Yeah, finally came to me. So Lance Spitzner, right, was one of the kind of founders of honeypots and the HoneyNet project, which goes in along with it as well. But and then he realized, right, the honeypots are great, but the idea is that the vast majority of attacks are successful because attackers are coming in because they're tricking our employees into doing something that they're not supposed to with social engineering, right? With like phishing emails. So that's how he made the transition from going from the very technical world of things like intrusion detection and creating honeypots to security awareness. And that's where, that's the world that he focuses on because he feels that he can have the greatest impact, which I really admire. So here's an example that Shodan, you can see that based off of the signature that it came back and they labeled it as a honeypot. And in this case, you can kind of look at the signature, and basically what it is, it just means is somebody had a honeypot, and a lot of these honeypot suites allow you to, you get a choice of emulate or simulate one of 30 different types of systems. In this case, they might have said, just emulate everything, right? Which is a dead giveaway. If a system looks like it's 30 different things, it's just a incorrectly configured honeypot. Again, which isn't one of the reasons why I wanted to write those other scripts. So it's just emulate a very simple, like an SL 1200, right? Just make it, and not worried about attackers interacting with it necessarily. It's just I want to get that quick alert if somebody scans it or touches it that tells me someone's on the network. Period. The end. Right. So, okay. Let's talk about Shodan searches, right? And this is where Shodan is a great tool. It scans the entire internet, right? It doesn't scan for all 65,535 TCP ports. Census does, actually. So that was where I was a little bit more impressive with Census. So Census scans all TCP ports. They don't scan all UDP ports. Remember, we had that conversation in one of the earlier parts because it's just too slow to scan UDP. Remember, there's no three-way handshake. So tools like Nmap, they don't have a way to truly measure is a port open or closed, and you just have to sit there and wait. And even then, the results are not very accurate. So it's just not worth it. So I'm going to jump over. Let's actually go into my GitHub repository, and let's go ahead and pull up. So we'll go to github.com/utilsec. Go to Quick Start Guides, and then we're going to pull up the one for Shodan for ICS OT. And then, again, I guess we can see it from here. I don't know if I can blow that up or. And I put this one together because it still has a lot of the common, like what you'll see in the IT side of the house. But like we saw in the earlier example, right? If I look up just what we're doing here, port 502, which is the port normally associated with Modbus over TCP/IP. Again, we just see every host that has TCP 502 open. So it doesn't matter if it's actual Modbus or not. Again, we saw a few instances of Modbus in there, but most of it's junk, right? So how do we really find control system assets? So I find better luck, right, when we start looking at using things like search terms. So even here, the example is SCADA. Right? Remember, SCADA is another term for if it wants OT or ICS, but SCADA are those types of implementations that go over a wide area link rather than being all locally situated. So things like in power transmission or water treatment where we're pumping, water across, long distances, and we might have a remote pumping station. But now we can see, well, what assets out on the internet in that Shodan's found, connected to, and sent additional requests to get additional information, and in any of those, the term SCADA pops up. So here you can see, here's some kind of web page that actually is asking for a login. So we see this basic realm for authentication, and in there it has 1509-SCADA. So again, I'm not going to look at the page, but potentially, right, it's some kind of SCADA system. In fact, actually it is, or probably what this is. So actually, this is bizarre. So I actually had a discussion with this about an engineer. Last week I have a project somewhere. It's in a very remote location, and they're looking at having to do a cellular connection from the site actually is spread out over 2 large areas. And so actually the micro hard systems actually came up in the discussion because they basically make these kind of cellular and wireless communication devices that you can put out. They're ruggedized, so they can sit out like in this area where it gets 30, 40 degrees below zero. And then it can even do things like VPN, so it can encrypt the data that goes over the wire. So this is actually one of those devices that we had talked about. So this could be, located at a plant. You can see like, in Canada, right up where it gets very cold. And so the problem with this, of course, this one's exposed directly to the internet. This was actually the conversation I had with the gentleman, with the engineer, because a lot of those devices and how they're implemented, they can be done usually over things like cellular, and then especially in that case, they get exposed directly to the internet, which is not what we want to have happen. So we had a long conversation about that. So it's funny that actually came up. So you can see, where is everything that says SCADA. Here, again, to me, that looks like another honeypot. It just has everything like listed on it. Right here, it looks like, there's some type of web page for potentially some type of SCADA. Right here, we see checkpoint firewall. Right, SCADA-firewall 1, SCADA-firewall 1, SCADA-firewall 2. Right, all within the same organization. SCADA-firewall-new. Right, that's probably another honeypot right there. So it's interesting when you start running searches for those specific terms. Again, not all of these are ICS or OT devices, right? Or these even might not actually be like IT/OT, but there could be like a Palo Alto or a Fortinet or a Cisco firewall, but it's still associated with an OT environment. And you can see, Imperial Valley Solar. So there's probably some type of renewable energy solar plant, right, running there, protected by checkpoint firewalls. And so you can see there's like 1,600 or 1,700 results for the term SCADA. Again, not all ICS OT, but some of these are related. Here you can see there's a database exposed to the internet, and one of the databases is named SCADA. That'd be interesting. Well, what kind of information is in that database? Here's another one. Two different databases in 2 different parts of China. Here we can find, here's another SCADA, right, on this TCP port 9 running. It's like the workstation service. Here's the MAC address for the host. Or we can take that MAC address and we could actually look up to see who the vendor is. That's in Kiev, in Ukraine. Maybe it's a honeypot for the Russians to try to attack. But you start to get the idea where you can run searches for these different types of terms. So I put some that I have better luck with, right? IIoT, right? Industrial Internet of Things, when we start taking our OT networks and pumping out data out into the cloud. Again, hopefully just send to the cloud, not have the data come back. Right? When you get to things like ICS and OT, since they're less specific acronyms and they're very few letters, you don't have as good luck, because there's a lot of words that contain ICS or OT on the internet, and so you're going to get a lot of results. So it's like you have to pick through. So you can find some worthwhile stuff, but at the same time, it's like, not really as well. I do like Siemens, or let's do like Rockwell Automation, because that was one of the examples we saw earlier, right? When we were doing the Google searches and the Elite Rockwell Automation, right? Searches from the ELITEWOLF project. Right? So here you can say, oh, show me now where I find a system connected to the internet and it has Rockwell Automation in the name. And it's like, boom, it's like PLC, 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 PLC. And what we can see is that, well, one is, right, we see the model device again, which I always like to, okay, Google, especially if I'm not familiar with it, right? And we can pull it up and say, oh, this is one of those assets that we're connected to. Very, very similar, kind of definitely same family, like the one that we were looking at earlier, right? So we have this PLC that we're connected to. You can see they have the little integrated screen. Some people might not even consider it like a full HMI, but it has a screen connected to it, right? We know it's Rockwell, right? We have a serial number. We understand, oh, and maybe it's the communication adapter that's connected versus, and then here you see like the programmable logic controller, right? It's very, I've seen this, and I actually have one of these micro logic series where you have the PLC, but the PLC by itself doesn't have the screen module. So you have to get that module to connect to it, and then you can use that to, like, as to take the module from like run mode to stop mode. There's not a hardware switch or key switch on the outside on the PLC itself. And then we can also see, oh, the private IP address of that model versus, of course, we also have the public IP address because, yeah, Shodan found it. And if you want, well, let's go ahead and click into one of these so you can see a little bit more of what the Shodan details looks like. So again, it says, oh, we scanned this host and we found 2 ports open. We found TCP 44818 and we found UDP 44818. And we did some additional queries for pieces of information. And yeah, that PLC, it told us its model, right? Probably the version of firmware that it's running, its serial number, what it is, and its internal IP address, right? That's not something that we want exposed to the internet. But we do see them exposed to the internet. Looks like this one's somewhere around Atlanta. So they even kind of do the little geo IP map in the background. And you can see the providers. In this case, yeah, we just see the ISP that it's on. We don't see the organization that's really associated with. But that's how you can use just by searching those names, where you can find different OT, assets that are connected to the internet, right? Or when I did the search for PLC, this is when I found that plc-city.com. But here you can see, oh yeah, boom, here's a PC works, PLC type, blah, 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 model number, blah, 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 firmware 4.6, right? So are there any vulnerabilities associated with this? Right? I can go ahead and I can just take this, remember, I can throw that into Google, and it's like, oh, there's one of those PLCs. They're ugly, aren't they? The Phoenix Contacts ones are definitely different than pretty much any other ones out there. I have one of these too. Not one of the green ones, but anyways, right? So that gives you an idea again how quickly it is to find these control systems that are exposed to the internet. Now again, the trick really from an attacker perspective is we don't know what that PLC is connected to. We know it's connected to the internet, but what does it control on the other side? What are the inputs and outputs connected to, right? What information is it bringing in? What signals is it sending out to control something in the real world? This is where, I think I mentioned at the beginning of the class, there was that classic story about those Iranian attackers that found what they claimed was a water pumping station for a water treatment facility in Tel Aviv, in Israel. And talking about how they compromised this water pumping station, for this water treatment plant in Israel. And it was a water treatment facility. It just wasn't a water treatment, right? Treating drinking water for, tens of thousands or hundreds of thousands of people. It was the water pump cleaning station for a hotel swimming pool. And so that's kind of really what it boils down to in control systems is once you get on a PLC, a lot of times you don't know what it's actually connected to. And so you have to reverse engineer that. And in that case, they figured, oh, it's a water treatment facility. They just didn't realize kind of the size and scope, and they blew that scope and size way out of proportion because when it really turned out just to be, yeah, this little kind of pump for, I don't know, doing chlorine for a pool at a hotel in Tel Aviv, not water treatment for tens of thousands of people. So you can see, though, how easy it is to find assets that are connected to the internet. Now, the number of assets, OT assets connected and exposed to the internet, it definitely has come down a lot over the years, for sure. But we can still see there's some out there, right? And these aren't all honeypots. You can say, oh, here's one that's labeled honeypot down below, right? Because you can see it just has it listed like they just turned on everything. That's a dead giveaway. And that's usually, and I've done that too. Like when I first turn on a honeypot, it's like, oh yeah, turn on everything. Well, again, you turn on everything, it's obvious it's a honeypot. Anyways, so you can do different terms. Again, I've had, a lot better luck, with the names like Rockwell Automation, Schneider Electric, right? Siemens. Now, if you do Siemens, though, there's just like Siemens everywhere for lots of things. And you see it on websites and certificates. So you have to sort through it to actually get to like the actual OT devices. You can do PLCs or programmable logic controllers even better because a lot of times you actually will see. Let me run this search real quick. And then when you pull it up, so you can see where all of those PLCs report back saying, oh, the device type is programmable logic control. Right? There's no question about what it is. So definitely you want to make sure you use the word spelled out. I think, at least for me, you get a lot more. You don't get, let's say, as many hits in total, but you get all accurate hits. Everything you're looking at is an actual PLC that we're looking for. So those are some of the examples that you find there in the cheat sheet. And you can put model numbers in there as well. So if I try like S7 1200, let's see if we get some of these hits, whether they're on the web pages or like here's one that was pulled over SNMP. They don't have SNMP restricted based off of a secure community string or a password. So it allows you to enumerate that device over SNMP. Yeah, I've seen the Siemens PLCs have SNMP enabled by default, which is the worst thing to have ever. But you can see because it just wants to share all of that information, which is great if you're an attacker or an administrator. But do you want that information exposed to an attack? No. So at least put a community string, a password essentially on SNMP, so just nobody has access to that information automatically. It just makes information, just makes it that much easier for the attackers. Right? So yeah, I mean, it just again the whole point of that quick start guide for the ICS OT version is to give you this idea of these different ways to run these searches to find ICS OT devices. Now another thing to think about though, which Shodan added this feature a couple years back, or at least I didn't find out about it until a couple years ago. Oh, it's probably been 7 or 8 years at this point, so it's been a while. But where you look at it, actually has an images feature now. So I think it is you have to have at least a paid account. But if you go to images.shodan.io, I don't believe it works with a free account, but I could be wrong. But you can see it finds anything that it can essentially take a screenshot, an interesting screenshot of, and indexes. Well, here you can see the vast majority of what it has are remote desktop instances for Windows login pages, which I do want to spend a minute on. And then you can also see there's also some webcams, right? Because you see like, oh, here's a stairwell, so maybe that's for security purposes. It almost looks like a kind of Chinese architecture from. I lived in China for 2 years, so it looks kind of makes me think China for some reason. And you can see also there's this webcam down below. If it still looks like maybe a site that like a building that's still under construction, like it's almost done. So a lot of times it's very popular, like at a construction site, people put up cameras to watch the plant or the environment being built over time. The problem is once it's built, they forget about the camera. And if that camera is on the OT network, and that camera is very easy for an attacker to take control over, that attacker now has a foothold on the OT network and never even realized it was there. That's one of those dangers with webcams. So we'll come back and look at webcams a little bit more particularly. But I always like to look at the remote desktop if you have these exposed and from the OT network, let alone the IT. It's fairly bad, right? Because you can click on there, and in this case, like in this example, right, we can see not only it's time to install Windows updates, which means they're not up to date on their security patches, but also they never renamed the default administrator name because we can see the administrator login. So now all we need is either the password to log in or an exploit for the system because we know it's not up to date on patches, right? It's at least missing patches from the last month's release. Remember, Microsoft releases their patches on the second Tuesday of every month. And it also pulls other information for things like, the name, right? VPS is like some type of virtual desktop, and you can see it's some type of hosted environment. So not necessarily going to use that to break into that target environment. But something like this gives me an idea it's probably a little bit more of a specific environment. Because now you can see not just the administrator account, but you can see an account for attendance. You can see one for Badar Din, Saqib Ahmed. Right? And then you can start to even see if there's any additional information to identify potentially the organization that this is exposed, that this is exposed to. And you can see, it's also running Apache Tomcat, right? So maybe, go ahead and open up that. It's just the default web page. So it's not going to give us an idea of who it belongs to. Maybe port 8080. Let's look at port 8080 and see. Oracle Application Express. Like, okay. I'm just trying to find an actual web page that actually would show us what it is. I'm not necessarily. Port 80 probably would be the one that would make sense to go to, wouldn't it? And then it's just this log, but it's like House of Business Machines Limited. This might actually be their machine, right? And maybe like Badar Din and Saqib Ahmed, work for this company, House of Business Machines, maybe. Right? Makes me wonder. But you never want to expose remote desktop to the outside world or many of these other services, right? Because remember, those ports, those are the doors and the windows that attackers can use to break into the house, or in this case, break into the system. So I'll reel myself back before we go too crazy, right? But there's a lot just to see, from remote desktop. If you put in just HTTP, it'll get rid of all the remote desktop sessions. So then you're left with the webcams pretty much. So it's really interesting, the different webcams that you can find. But we're going to look, there's always like people's bedrooms, right? For better or for worse. I get really freaked out when like you see some like kids, like I understand a parent want to watch, what's going on in a kid's bedroom, like when they're sleeping, but you don't connect that to the internet. There are a lot of bad people on the internet. Right. You can see a lot of, like stores. Sometimes you see like gyms or like here, like, right, security gates, someone's backyard pool, right? Traffic, right? More, roads. You see a lot of cameras watching billboards because, billboards always like to get vandalized, I guess. Or they get vandalized. I don't think they like to get vandalized. So you'll get an idea why I'm paging through a lot of these though. So again, we say, here's it looks like a car dealership, right? Looking out over the city, watching snow maybe on the lake, right? There's just webcams everywhere. Again, webcams are fairly typically easy to take control over, and you can use it to gain access to the network. Like in this case, right, here's a camera in a store. What if I hacked that camera, took control over it? Then I would be on the store network. Or what if I find a camera and we're still trying to find one in more of an OT environment, right? And I have some examples to show, but it's nice when I can find one. Like in this case, this is probably one associated with rail. So that camera could be on the OT network for that railway. And then if I hack that camera, then I'm actually on the OT network. And then could I potentially use that to take control or impact operations of that rail network, right? That could definitely be a concern, right? Does this girl know that her webcam is exposed to the internet? Right? This looks like maybe a gym. And ultimately, here's where I was going. Well, and this is great because on this page, there's two great examples. Because one, even though it probably is like maybe a brewery, it's still an example of an OT environment that's exposed to the internet. Again, we have a camera in an OT environment, and we'll go ahead and open that one up. And then, yeah, it's definitely a brewery, right? But and so we have this webcam. Let's say it's an OT environment. We'll treat it as a petrochemical facility. Right, so now, if again I take control over that webcam, I'm now on probably the OT network of that petrochemical facility. That's why webcams never put them on the OT network. Don't put them on the IT network. Put them on a completely separate network. So, and then you can actually see the company that this is actually associated with, right? So it looks like Sazerac.com. So we could look up Sazerac.com and see what actually it is. Yes, I'm over 21. So here's, I didn't know we were going to get this great. Oh, the hotel. Oh, yes, luxury hotels around the world. I've actually seen a few of these. Very interesting, and then very cool. And then all of their liquor. Very cool. So that's where you can kind of bring it full circle. So that one I suspect is probably the Kentucky location, but I could be wrong. Just based off of the American Buffalo. But so the other example we were looking for is this one right here. So let's pull this one up so we can see it. In this case, it's not the perfect example, but where I'm looking for more like a traditional like HMI. But here is like, it looks like you have like this device and it just shows different pieces of information like temperature and humidity, right? This is very common like things that you would see in data centers, and maybe there's even different views. I don't know. We can see if there's a couple of other potential options. Let's see. Usually it doesn't take too long to find an HMI, like a real HMI. But if these don't work, I do have kind of like little OT environments, I guess. Looks like somebody ironing in his house. Always, like I said, you get to see a little bit of anything and everything. But I'm really just looking for a lot of the HMI. Thankfully, I mean they're getting taken offline more and more, which is great, right? Because if they don't, they get hacked, and then they get taken offline. So it is becoming harder and harder to find them. Usually, I would have found one by now. So here's a terminal that looks like it's been exposed to the internet. Okay, we'll try one more. And if that doesn't work, no luck. Okay, so instead of wasting everybody's time, let's go back to the slides because I do have some other examples. So we talked about the remote desktop example. Now here's some more, I think, better examples of webcams or CCTV in OT environments, right? Like on the right-hand side, you can see obviously a water treatment plant. On the left-hand side, I think this was just mostly kind of different like highways and roads, but it was also this idea where you have multiple cameras in one interface, which I thought, was a great example to also show, right? And what if this, water treatment facility is under our protection, right? We're trying to protect it. Again, we want to find this exposure and we want to get it fixed because again, that camera is on the OT network more than likely. The attacker gains access to the OT camera, then they have a foothold on the OT network. So here's another example of now more of an HMI that we were looking for. Now, a lot of times these HMIs, they get exposed to the internet. They're usually behind a device that exposes them to the internet in a read-only manner. So just because you find an HMI connected to the internet doesn't mean you can just start clicking on buttons and making changes. Sometimes you can, though. Sometimes you can't. Most of them are read-only. So it's like, well, okay, at least you're putting it on the internet in read-only fashion so you can see what's going on, but you're not actually making changes. So it's like, I get that. So that's not as bad. Just remember that device that still it's exposing it to the internet. It can be compromised. And if it can be compromised, the HMI can be compromised, and then the attackers have access. So just don't expose them to the internet. If you ever need to access resources on the OT network, make sure it goes through secure remote access, which we're going to be talking about later in the course. So remember, secure remote access. Don't expose anything directly to the internet. The other thing to think about is that most HMIs, right, those are now web interfaces, right? So it's actually a web page sitting there running as a web server on the HMI, or sometimes the HMI is also running on the PLC. So not only does that web interface have vulnerabilities, but the web server has vulnerabilities, and the PLC or the firmware has vulnerabilities. So again, it's just, if we expose these to the internet, we're exposing all those vulnerabilities. We're making it way too easy for the attackers, let alone here they have an understanding of a process you have in the environment. They see how it works, how it operates. They can watch it even over time. Again, even if it's only read-only, it gives them information to understand what's there, what's in the environment. It helps them reverse engineer. So if they do gain access to the environment, it gives them, again, more pieces to the puzzle. They're building that Sudoku puzzle where they're filling in all those blanks to where, can I get into a position where I can use this process to create an explosion? That's not something we want to have happen, especially when I see the words chemical drum and peroxide, right? There's substantial risk. So that's the idea, Ken. We don't want anything exposed to the internet. You want to access that HMI remotely, do it over secure remote access. If you do want to make it, you can push it out in, kind of that send out to the cloud in one way, but never allow return traffic. Okay, we'll circle back on and all that when we talk about secure remote access. Now, one thing we kind of have brushed across, which we normally wouldn't do if this was like a pen test course. Because here we've just been talking about finding ICS and OT assets on the internet. We haven't been talking about finding them associated with a particular entity, right? So what if I'm doing a pen test for a particular organization or company, or I'm an attacker and I'm looking for just a specific type of attack, right? Then I want to find those systems that are associated with just that company. Let's get rid of our images there. So maybe let's say I want to search for all of the Shodan results in the subnet of 189.167.8.0/24. So basically it's the Class C equivalent of the subnet on which this device is sitting on. Because maybe there's also some other interesting findings related along with this one, right? Because we can see there's 26 different results. So here there's this axis camera, right? That at 1.4 or .114. Then here's something at .100, right? It's this. Let's look that up. So it looks like some type of like DVR for recording the cameras. We can look at, just trying to see if there's anything else of interest, right? We can see what else might be associated, or try to track down what type of organization. So here you see things like Don Domino, Mr. Domain. I say probably not going to be able to use to track down the uh, the entity, right? There's a lot of exposed devices though. Oh, here's another DVR, right? There's a lot of exposed devices that could potentially have a lot of vulnerabilities, so that we see on the network. So a lot of interesting items of note. Anyways, again, before I digress too far, so I just want to wrap up, say I appreciate everybody for coming. Thank you for the time, for checking us out. I always have a lot of fun doing the OSINT parts. So hopefully bear with me, because I do like to go on lots of tangents. I could have probably spent 40 hours easily on some of those things that we were looking at. But if you have any questions, comments, concerns, reach out to me on LinkedIn. There's my email address. Obviously, you know where the YouTube channel is, and you can find me at mikeholcomb.com. But if you like the video, please like or subscribe. If you're not subscribed already, I appreciate it. And I will see you in part 8. See you then.